FP1 numerical methods, example 7. Part A is the standard part A to these sorts of questions, where it asks us to show that this particular equation has a root in a certain interval. Now remember, if it's not equal to 0, your first step is always to rearrange it. So I've rearranged this equation here, and I've made it into something I've called fx. So we want where this fx is equal to 0. So I substituted in two endpoints, 0.5 and 1, looked for a sign change as usual, and I've written the sentence as we have to do. A sign change indicates that we have a root. So that's part A. Now part B is asking us to do the Newton-Raphson method twice. So we know that the first thing we're going to need to work out is f-x. Differentiating this, we get 3x squared minus 12. And so we know that when we do our iterations, it's going to be f of xn on the top and f dash of xn on the bottom. So always write out the formula. So it's telling us our starting point, x1 is 0.5, and so x2 will be 0.5 minus f of 0.5, so put 0.5 into the original equation. That's the numerator. And on the denominator, we want f dash of 0.5. Here it is. So it's 3 times 0.5 squared. Remember to square the 0.5 before you multiply by 3. And then subtract 12. So if you pause the video, substitute it into your calculator and see what you get. And I got a nice round number, 0.6, when I did that. So that's our second approximation. And then we want one more, because it said it wanted two further approximations. So it's 0.6 minus, substituting in 0.6 like we did with 0.5. It seems a little bit long-winded writing all this out, but it is the method, and these can be worth quite a few marks, so it is important to show, just in case you get your answer wrong, that you knew what you were doing. So pause the video again, work that out. So you've got f of 0.6 on the top, f dash of 0.6 on the denominator, and I got for my answer something like that. And it wants the final answer to 4 decimal places. So alpha, this root that we're aiming for, is 0.601, and it would be 5, wouldn't it, for the 4th decimal place.